All right, today we are learning section 2.3, simplifying variable expressions. Simplifying variable expressions. Now, before we get into the lesson, we're going to basically break down an expression into its different parts. We're going to identify the constants, coefficients, terms, and like terms. All right, so I want you to write this expression down in your notes. We're going to now write definitions. Okay, now the definitions for these, you need to write them down. I'm going to tell you what I want you to write down. A constant, write this down in your notes. A constant is a number that stands alone in the expression. It's by itself. A number that stands alone. Coefficient is the number in front of a variable in a term. Okay, so within a term, it is the number in front of the variable. Within a term, it is the number in front of the variable. That's a coefficient. So in your definition of coefficient, I want you to say the number in front of the variable. The number in front of the variable. That's your definition. A term is the individual parts. So for terms, say parts of the expression. Parts of the expression. That's a term. So, and it's always separated by your plus sign. So each one of these are what we call terms. A term is the parts of an expression. Parts of an expression. That's a term. Like terms are similar parts of an expression. They are the ones that we can simplify. So they're the parts of the expression that can be simplified. Those are my like terms. We're going to identify now the parts of the expression. So my constants are what? What are the numbers that stand alone?
7 and 12.
7 and 12. Very good. All right, so my constants are 7, and I separate the terms by commas. 7, 12. Those are my constants. My coefficients, the numbers in front of the variable, are
5x, 4x.
Hold on, not the x, just the number. And I have to pay attention to the sign. Notice I just changed the sign in front of the 4 because I want to point something out. You have to pay attention to the sign in front of every term. 5 is clearly positive. But 4, since there's a subtraction sign in front of the 4, I'm going to say that it's negative. So my coefficients are 5 and negative 4. Now my terms, guys, I'm just going to write basically my expression without the plus sign. 5x, and then 2. 2 is also my coefficient. My terms are 5x, negative 4x, 7, 12, and 2b. It's just basically the expression without the addition signs. Those are my terms. Now, we've talked the other day about like terms. Remember, like terms I can simplify. Does anybody see a group of like terms that I could simplify here? Why? Very good. 5x and negative 4x. So I'm going to group them inside a parentheses. Okay? My like terms, I'm in a group inside parentheses. 5x, and make sure you write your sign because you'll get a point off for that, negative 4x. What's another group of like terms?
7 and 12.
Very good, 7 and 12. Now, are there any other b's besides 2b? No. Is there anything we can combine it with? No. So it doesn't have any like terms, so we don't even include that one in like terms. Does that make sense? There's got to be 2 for it to be like terms. There could be 3, there could be 4, but there's got to be at least 2. Now I'm going to simplify. I'm going to combine my like terms and simplify the expression. So what's 5x minus 4x? Just 1x. And you can just write x, okay? The 1 is understood. Now if you write a 1, I'm not going to count off, but the proper way to write it is an x. And then what's 7 plus 12?
19.
And then my 2b. And that's my simplified expression. Okay, so now in example 1, that's exactly what we're going to do. We're going to break it down into its parts. All right, so you can abbreviate. We've got terms, like terms, constants, coefficients. Okay, it's getting a little too cramped. Terms, like terms, constants, coefficients, and then we have to simplify. Well, let's not simplify yet. We'll leave that for the next one. All right, so terms, like terms, constants, and coefficients. All right, so terms, again, I'm just listing the expression except no addition or subtraction signs. Or I'm sorry, no addition signs. So y, 8, negative 5y, and negative 3. Okay, and then my like terms, what's going to be one set of like terms?
Y and 5y.
Y and negative 5y. And what's my other one?
8 and negative 3.
8 and negative 3. Zach, you got that? Following along? Okay. All right, and then what about constants?
8.
Grayson, what'd you think? What are my constants? My numbers that stand alone. Isaiah?
8 and negative 3.
Very good. 8 and negative 3. My numbers that stand alone. Now, what about my coefficients, Colin?
The coefficients would be 5.
Close. Negative 5 and 1. Very good. All right, so I want you to do the same thing for B. Tell me the terms, like terms, constants, and coefficients. What are my terms? It's just listing them out, right? X, negative 4, 3x, negative 7. What about my like terms?
X, 3x,
X.
4, negative 7.
Very good. Negative 4 and negative 7. What about my constants?
Negative 4, negative 7.
Perfect. And what about my coefficients?
3,
1 and 3. Perfect. Who got them all right? Good job. Awesome, guys. Very good. All right, now in example 2, now we're simplifying the expressions. We're just combining like terms. We're not worried about listing out constants, coefficients, any of that. All we're doing is simplifying. Remember, there's an understood 1 in front of variables that don't have a number in front of them. All right, so on A, now here's the most important part about simplifying expressions. Pay attention to the signs in front of the terms. All right, and apply your rules for adding and subtracting integers. So if I had 4n minus n, what would I get?
Negative 3n.
Just 3n, right? 3n because there's an understood 1, and 4 minus 1 is 3. Now, what about negative 7 plus 9?
2.
That's just 2 because you subtract and take. 9 is the greater absolute value, so 3n plus 2. There's really no work to show unless you want to use commutative property to group them together, but it's just going to be 3n plus 2. All right, now I want you to try B. You try B. Yeah. All right, so 8x plus x is what, guys?
9x.
9x. Very good. 22 minus 10?
12.
All right, who got that right? Awesome. Good job, guys. Good job. Okay. All right, so now what about C? I have negative 3x minus x. Same sign or different? Same. So what do? Add and keep. 3 plus 1 is 4. Keep your negative. Negative 4x. Now what's 8 minus 4?
4.
4x plus 4. Negative 4x plus 4. All right, who got that one? Yeah? Okay. All right, very good. So that's it for example 2. Negative 4x. Add and keep. All right, now in example 3, okay, there's going to be 2 steps here. There's going to be 2 steps here. The first step is to get rid of what's in parentheses. But can I do x minus 4? No, I can't. So what do I have to do? We learned the other day. Distributive property. Multiply what's on the outside by every term inside the parentheses and pay attention to your signs. So 2 times x is what? 2x. 2 times, don't miss this, negative 4 because there's a minus sign. 2 times negative 4 is negative 8. Now I can fill in the rest of my expression. And now I can combine my like terms. Okay? So first step, distributive property to get rid of parentheses. Then I can combine like terms. What's 2x plus 9x? 11x. What's negative 8 plus 1? Negative 7. 11x minus 7. So to answer your question, Wesley, that's why it's a minus 7, because 7 is negative. All right, so that's how I know what sign goes in between the terms, because it's a negative 7. If it was positive 7, it would have been a plus sign. Okay, so now I want you to try B. Try B, and then we'll go over it. All right, so 3k minus what? 8k. What's next? Minus 16, right? What's 3k minus 8k?
Negative 5k.
Very good. Negative 5k minus 16. Because you cannot forget that the 8 is negative. The 8 is negative. Okay, so that's why. Anybody get that right? Negative 5k minus 16? Did the negative mess you up? The negative? Right, now, C is a little bit different because there is no number between the subtraction sign and the parentheses. Anytime there is no number between the subtraction and the parentheses, I'm going to place an understood 1. An understood 1. If there's a subtraction sign and then a grouping, a parentheses, I'm going to place an understood 1 there. Okay? So 4a, all right, what's negative 1 times 4a? Negative 4a, right? Minus 4a, and then what's negative 1 times negative 3? 2 negatives, positive 3. Multiplying. We're multiplying here, guys. Okay, so plus 3. Well, 4 minus 4, those cancel, and so my answer is just 3. All right, so in our last example, we're finding perimeter. Say I've got a width of 2x and a length of x plus 5. And I said, find the perimeter of this rectangle. Well, how can I find perimeter? What's my formula? Very good. Perimeter equals 2 times the length plus 2 times the width. So, perimeter equals 2 times x plus 5 plus 2 times 2x. Now I just do distributive property. P equals 2x plus 10 plus 4x. Final answer? That it?
No. Yeah.
Why isn't it my final answer?
You have to
I have to, they're very good. I have to combine my like terms, so P equals 6x plus 10. What if I had this triangle and I've got x, 3x, and x plus 4? How do I find the perimeter of our triangle?
A plus B plus C.
Just add them all together, right?
Yeah.
So now, perimeter equals A plus B plus C. Just add my sides together. So perimeter equals x plus 3x plus x plus 4. All right, you try to simplify that. All right, Wyatt, what's my answer? P equals 5x plus 4. All right, and if you understand that, that's everything you need to know for 2.3.